First of all, acknowledgement. The final product of this assignment would not be possible without the guidance of our lecturer, Dr. Siti Nur Awani Saleh. Thank you for your patience and support, and also for all the soft reminders that keep us on track. This assignment also could not be completed without the amazing effort and cooperation from our group members, especially our leaders, Ahmad HAZEEM, who lead us through this assignment, and other members, KHAIZAL, DANIAL, AZROL, and BALQIS. Introduction. Application of differentiation related rates. What is differentiation? Differentiation is a process of finding the derivative or rate of change in function using one of its variable with respect to another variable. If x is one variable and y is another, then dy dx is the derivative of y with respect to x. This is the general expression for function's derivative, and it is written as f prime x equal to dy dx with y equals to fx being any function. This is basic differentiation rules. Without using the formal definition of the derivative, we can compute the derivative of such function using basic differentiation rules. This is the rules: sum and difference rule, product rule, quotient rule, and chain rule. Application of differentiation in life. We can calculate the rate of change of one quantity in relation to another using differentiation. Here is the example. We can use the differentiation to calculate the speed or distance covered between vehicles. And we can also use differentiation to calculate the maximum and minimum values such as cost and profit or loss. Related rates. The definition of the related rate is rate of change connected with two or more related quantities that are changing over time are referred to as related rates. We can figure out how the variables are related and how fast one of them is changing if we know how the variables are related and how fast one of them is changing. The main idea here is to use the rate of change of other quantities to calculate the rate of change of one quantity with respect to time.
Problem statement for related rates. Let's take a look at past year question January 18 for related rate problem statement. A conical water tank has a radius of 3 cm at the top and 15 cm high as shown below. Water flows into the tank at a rate of 6 cm³ over second. Hint: volume of cone equals to 1/3 times pi times r square times h. As we can look at this picture, we can see that the radius for the cone is 3 cm and height is 15 cm. For the question A, show that the volume of water is given by V equals to pi h³ over 75. To solve this problem, we need to use differentiation to show that the volume of water is V equal to pi h³ over 75. B, how fast is the height changing at an instant when the height of the water is 5 cm? From this question, we need to find rate of height changing at an instant, that is dH over dt. To find dH over dt, we need to use dV over dt, that is 6 cm³ over second, and dH over dV. My friend's gonna show you how to solve these two questions.
Okay, now let's have the look on the question that use the related rates concept. Okay, look at this question. A conical water tank has a radius of 3 cm at the top and 15 cm height as shown below. Water flows into the tank at a rate of 6 cm squared 6 cm cube per second. Okay, now we got the radius. Okay, this is the radius. The radius is r equal to 3 cm. And then we got the height. This is the amount of the height. H equal to 15. Okay, now we got the third information is rate of change of volume. So we got dV over dt equal to 6 centimeters cube per second. Okay, now after we list all of this information, we can proceed to the sub-question A. Show that the volume of water is given by V equal to pi h cube per 75. Okay. Now to solve this question, we need to use the ratio technique. So A, we use the ratio technique between R and H. So R per H equal to 3 over 15. And then we simplify to the simplest form. 3 equal to 1, 15 equal to 5. So we got 1 over 5. After this, we need to express R in terms of H because we want to use the amount of R in terms of H. So R equal to 1 over 5 H. Okay, now we insert this amount into the general formula of cone. Okay, the general formula volume of cone is V equal to 1 over 3 pi R squared H. And now we replace this amount in R. 1 over 3 pi 1 over 5 H squared H. After this, we solve this equation. 1 over 3 pi 1 over 25 H squared H. So we got pi H cube over 75. So we prove this expression as shown in the subquestion A. So we finish subquestion A, and now let's read the subquestion B. How fast is the height changing at an instant when the height of the water is 5 cm? So we got the other information, H equal to 5 cm. So how to solve this subquestion? We need to use the amount of volume that we got just now. So we use back V equal to pi H cube over 75. So we want to find the how fast the height changing. So we want to find height changing. So we want to find the rate of change of H, rate of change of H equal to dH over dt. So we want to find dH over dt. How to get dH over dt? dH over dt equal to dH per something times something per dt. Okay, based on the information that we got early, we got dV over dt. So in this box we can replace it as dV. So how to find the expression to replace in this box? Okay, as we know, if we want to find dH over dt, both of these cross side must be same. So we use this as dV because we can simplify all of them equal to 1. So we can got dH over dt. Okay, after that, how to find dH over dV? We can find uh, through this equation. V of equal to pi h cube over 75. So dV over dH equal to 3 over 75 pi h squared. So this is the answer for dV over dH. So we simplify it to the simplest form, 1, 5. So the 1 over 5 pi h squared. Okay, after we got this answer, we need to replace to the formula that we made just now. dH over dt equal to, what's the amount of dV/dt? 6 centimeter cube seconds per second. So 6 times, okay, in this formula we write it as dH over dV, but we find dV over dH, so we need to transform into the dH over dV. How to write it? We write it as 1 over 5 pi h squared. Okay, now we solve this equation. Oh, I'm sorry, this is 1 over 25 and this is 1 over 25. One over 25 and 1 over 25. Okay, now we replace the h as we got in the question. The h is equal to 5 cm, so we replace it as 6 times 1 over 25 pi 5 squared. Okay, and now we got 6 times 1 over 1 sorry 1 over 25 pi 25 times 25. So we got we can simplify both, equal to 1. So we got 6 times 1 over pi, and the answer is 6 over 5. So we solve all of the question of related rates concept. So that's all from me. Thank you.
Assalamualaikum. I will continue with the conclusion. Why the rated rates are important in the real life? Rated rates are very important because there are many real life applications of it, like a snowball melting, a ladder falling, a balloon being blown up, a stone cutting a circular ripple in a lake, or two people moving away from each other at a right angle. The conclusion of the solution. Based on the question, for solve the question 1, we use ratio analysis problem to get the quantity of proof. In the question 2, the differentiation also can use to solve the question of rated rates. For example, we use a differentiation to find how fast the head changing. Lastly, after we use the ratio analysis problem and differentiation, we can solve all the question problem in the rated rate question.